Thank you for staying with me on our VAR and impulse response function series in Stata. Please, before you go ahead to watch this video, endeavor to watch these prerequisite videos listed on the screen. It is important for you to know how to test for stationarity, how to determine optimal lags for the model, how to estimate a simple VAR model, and discuss the results. As a continuation from the first video I did on impulse response, we are still using this 3-variable VAR model you can see on the screen. And what we are going to do in this tutorial is to take a practical example, estimate the VAR model, extract the impulse response, and interpret the results. These are the step-by-step procedures as shown on the screen. Because I've told you to watch those prerequisite videos, I'm going to skip steps 1 to 3. So I will only do step 4 to 7 in this video. So now we are in Stata on the screen. And the variables I'll be using in their log forms, PDI, PCE, and GDP. And in my usual practice, I have my log file on to track all estimations I'll be doing. And also I have my do file in place with all the commands to be executed. The first command I'm going to execute is the tset quarterly command to prepare Stata to run all time series analysis. I've done this before, so let me show you the outcome. So here is the outcome for the tset command, showing that I have a quarterly data from 1970 quarter 1 to 1991 quarter 4. So remember, I'm skipping step 1, 2, 3. I'm going straight on to step 4. This is the command for step 4, var basic, where all the variables are listed. The outcome variable is always listed first. And I'm using 2 lags for the model. If you want to know how to use the menu approach, let me show you. You click on statistics here, maneuver to multivariate time series, then you click on basic var. I've been here before. So you can see all the variables are still as shown, listed, PDI, PC, GDP, all in their log forms. I'm using 2 lags as indicated by the information criterion that I'm using. By default, Stata indicates the orthogonalized IRF. But if you don't want that, you can click the ordinary IRF if that is your desire. But I want the orthogonalized, so I'm indicating that. I want to see the impulse response function for 8 periods. So I'm going to leave the horizon at 8. Every other thing looks fine. I click OK. This has been done already, so let me just go straight to the results. So here on the screen is the result from the VAR estimation. And because this tutorial is only on impulse response, I will not be discussing these results. If you still don't know how to interpret your VAR results, please watch my video that I showed you before on how to estimate VAR and discuss results. So let me move on to the graphs and interpret them. So these are the IRF graphs as populated by Stata. You have the VAR basic, you have the impulse variable listed first, and you have the response variable listed next. So how do you even read the labeling? Let me use this graph as an example, where you have VAR basic, log of GDP, and log of PCE. What this graph is simply showing you is the impact or the response of PCE to a 1 standard deviation shock to GDP. So this graph is showing the response of the log of PCE to a shock to GDP. Because GDP in this case is the impulse variable and PCE is a response variable. So I've copied this graph neatly to a PowerPoint slide with better annotation, so I can give you more in-depth interpretation. Here on the screen is the IRF graphs as populated by Stata. And to simplify results, I'm only going to limit interpretations to the responses of GDP and PCE to shocks to PDI. Meaning I'll only be interpreting these 2 graphs. Once you can get the understanding, you can use that to also interpret other relationships in the impulse response function. So the basic question is, how will PCE respond to a standard deviation shock to PDI? From this graph, we can see that between period 0 and 1, PCE initially increases, it is positive. Afterwards, there is a gradual decline in PCE. It gets to a stable state between period 3 and period 4, then it begins to rise from period 4. So you can easily conclude that the response of PCE to a standard deviation shock to PDI is an increase in the short run and also an increase in the long run. The short run period can be characterized as period 0 and 1, and the long run period can be characterized as period, let's say period 4 to 8, because at those periods there's an increase in PCE. So what will be the response of GDP to a standard deviation shock to PDI? Almost similar to what was obtained in the response of PCE to PDI. We can see here that if there is a standard deviation shock to PDI, GDP will initially increase in period 0 to period 1. From period 1, there is a gradual decline in GDP up to almost period 4. Between period 4 and period 6, GDP is in a stable state. And from period 6 upward, GDP witnesses an upward trend. So you can conclude that in the short run and in the long run, GDP will have a positive response to a shock to PDI. So this is how you can interpret this result. So impulse response function gives you more information about how variables in the system will respond to a standard deviation shock to another variable. So I've just simply analyzed the responses of PCE and GDP to a standard deviation shock in PDI. And you also observe that the graphs, that is the IRFs, are within the 95% confidence intervals in both places. Also observe that on the vertical line here, you have 0, and above 0 is a positive number, below 0 are negative numbers. So if the graph is above the 0 line, you can say is a positive response. And if it's now below the 0 line, you can say there is a negative response. So overall, GDP and PCE exhibit positive responses to a standard deviation shock to PDI. So the explanations I made, you can see them all here if you want the notes. So these are the explanations. The response of PCE to a shock in PDI is a positive response. So PCE will increase positively both in the short run and long run. Same thing GDP. GDP will increase positively both on the short run and on the long run. So next we are going to perform some diagnostics. Let us check stability of the model for normality and also for autocorrelation. Normally, the approach will be for you to estimate the VAR, check for diagnostics before you conduct impulse responses. But the way Stata does it is that it will compute the IRF and the VAR estimation at the same time. But it's still always good for you to test for diagnostics. So let's do that right away. I have all the commands here, so I'll just simply highlight them and run. So here you have the result for the autocorrelation test. At 1 and 2 lags, we cannot reject the null hypothesis of no autocorrelation, so this is good. For normality, we can see here that overall, the errors are normally distributed in the model. And looking at the result for stability, all the eigenvalues lie within the unit circle, so VAR satisfies the stability condition. And I also have the graph here. The graph here also shows that all the eigenvalues lie within the unit circle. So our VAR model is stable. So our inferences from the IRF function can be taken seriously. So in conclusion, always know that your innovations and responses must be consistent with intuition, with economic theory, or a priori expectations. For instance, our results are consistent because with more income, people tend to spend more, that is, expenditures go up, leading to more consumption. This creates more demand for production. Investment opportunities go up, leading to economic growth. So your IRF graph must be consistent with economic theory, intuition, or a priori expectations. If you need more references or readings on VAR and impulse response function, please look at all these textbooks and journal materials and see how the estimated impulse response functions and also interpreted the results. It's been wonderful having you. Thank you so much for watching. Subscribe to my channel if you have not done so. CrunchEconometrix is solely dedicated to beginners and intermediate users. Please don't go away. I'll be right back with more interesting videos.